Good evening, everyone. Tonight we're going to be talking about writing the equations of special segments. So first, let's review three of our special segments. First, we have a median, and we know the median connects the vertex to the opposite midpoint. We have the altitude, which is the perpendicular line from the vertex to the opposite side. And then a perpendicular bisector, which is the perpendicular line at the midpoint of one of the sides. All of the examples on this video are going to come from triangle DEF, where D is at 2, 5, E is at 8, 3, and F is at 2, 1. So go ahead and graph these 3 points and connect your dots to draw the triangle on the graph on your paper. So in this example, given triangle DEF with D, E, and F at the places I already mentioned, write the equation of the median from D. Well, we know that the median connects the vertex to the opposite midpoint. So that would be the side opposite D. So we're looking for the vertex D and the midpoint of EF. So to find the midpoint, I'm going to stack them, add them, divide by 2. So I'm going to stack point E and F on top of each other. Add them together to get 10, 4. Divide by 2. And so then the midpoint of EF is, I'm going to call G, is at 5, 2. So now that I have 2 points, I'm missing a slope. So I need to find the slope between D and G. So y2 minus y1 over x2 minus x1 will give us the slope of DG. So in this case, that's 2 minus 5 over 5 minus 2, which gives us negative 3 over 3. So our line DG, our median, has a slope of negative 1. So now I have a point and a slope, so I'm going to use point-slope form, which is y minus y1 equals m times x minus x1. So I'm going to plug in y minus 5 equals negative 1 times x minus 2. I'm going to distribute the negative 1, so I'll have y minus 5 equals negative x plus 2. Add 5 to both sides. And so the equation of the median from D is y equals negative x plus 7. Now, using the same triangle as before, triangle DEF, let's try to write the altitude to DE. So we know that the altitude goes from the vertex to and perpendicular to the opposite side. So, since we want the altitude to DE, the vertex is going to be the vertex opposite DE, so that will be point F. So from point F at 2, 1 to the perpendicular slope of DE. So to find perpendicular slope, first we must find the regular slope of DE. So we know our formula is y2 minus y1 over x2 minus x1. So we're looking for the slope of DE. So that will be 5 minus 3 over 2 minus 8, which gives us 2 over negative 6, which can be reduced to negative 1/3. So DE has a slope of 1/3, and we want the perpendicular slope of DE. And we know that perpendicular slope is opposite reciprocal, so we're going to flip the fraction and change the sign. So a slope of negative 1/3 would be perpendicular to a slope of 3. So now we have our slope and our point, and so we're going to plug into point-slope form. Y minus y1 equals m times x minus x1. So that's going to be y minus 1 equals 3 times x minus 2. So when I distribute, I get y minus 1 equals 3x minus 6. Add 1 to both sides. And so the equation for the altitude to DE is y equals 3x minus 5. And the last example for today, we are going to find the perpendicular bisector of EF. So if we recall, the perpendicular bisector is perpendicular at the midpoint. So we're going to need to find the midpoint of EF and the perpendicular slope of EF. You may recall from earlier that we've already found the midpoint of EF. So we stack them, add them, divide by 2, stack E and F together. When you add down, you get 10, 4, divide by 2, and so that gives us our midpoint of EF, point G, at 5, 2. Next, we need to find the perpendicular slope of EF. Before we can do that, we first must find the regular slope of EF. We know our slope formula is y2 minus y1 over x2 minus x1. So that's going to be 3 minus 1 over 8 minus 2, which gives us 2 over 6, which can be reduced to 1/3. So if we want to find the perpendicular slope to 1/3, we know we need the opposite reciprocal. So we're going to flip the fraction and change the sign. So that means that our perpendicular slope to EF is going to be -3. So now we have a point and a slope. So that means we're going to use point slope form. Y minus y1 equals m times x minus x1. When I plug in what I have, that's y minus 2 equals -3 times x minus 5. When I distribute my -3, I have y minus 2 equals -3x plus 15. I need to add 2 to both sides. And so now we have that the equation of the perpendicular bisector of EF is y equals -3x plus 17.
I believe I can fly. I believe I can touch the sky. I think about it every night and day. Spread my wings and fly away.